Welcome to episode 39 of the What's Up podcast, recorded on the 28th of August 2019. My name is Martin.
I'm Ali.
And I'm William.
We're going to go through a few headlines that have caught our eye recently and try to put a bit more science behind the headline. For our regular listeners, though, I should point out we have missed a month. This was deliberate, although we forgot to mention it last time. We decided to take a month off this summer to try and get ourselves a bit sorted out. So we've managed to get the podcast listed. We've sort of rebranded the podcast a little bit. You shouldn't have noticed very much changing, but the title has changed a little bit. We're now listed on Spotify and a couple of other sites. We trying to change our media presence a wee bit, and it took us a bit of time.
Holiday.
And the idea was also, take a break, try to recharge the batteries. But we're coming back in here, sitting in a very warm room, all of us tired after a week's hard work.
I'm still tired. There was some moon thing happened last month, so I've been quite busy running around with my Lego rocket, pretending I know more than I do.
Yeah, I think our relaxing month hasn't been that relaxing, but we're back now. We're back to our normal schedule.
The sun is shining. Yeah.
So we'll try and go through a few stories. The headlines this time, we're going to cover some misleading headlines, some odd headlines, and some super fresh headlines as well. So kicking off with the odd headline, there was a headline that hit the press in the last couple of months, which was about tardigrades on the moon. Ali, what?
Oh, this was a fun one, but it also it ties in with something that's kind of definitely worth talking about, and there's a few questions involved with this as well. So we've already talked about the Bereshit Lander. Have I pronounced that correct? So Bereshit. Israel were trying to land a probe on the moon, which is kind of cool because first nation other than Russia and America to do so, I think, is that.
And the first private.
China have now done it, obviously, as well. So sorry. And first private initiative, didn't work.
Well, no, it did land.
Made a moon-shaped hole.
It landed very hard.
And it turns out that it was carrying an interesting payload. So as well as science instruments, it was also carrying something by the slightly shadowy titled ARC Foundation, and it's to do with this is a foundation that's Microsoft is one of the backers, apparently, if you go to their website. The website's it's not got all the information for somebody like me who wants to dive in and go, but explain. And they have the very noble goal of trying to preserve and archive all of human history, knowledge, for future generations and or alien civilizations to uncover when they arrive. They can find one of these arcs that the ARC Foundation is making, and ostensibly they are figuring out ways of preserving data for a very long period of time. So none of this, do you send a DVD or solid state storage? They're actually coming up with fun and arguably quite innovative ways of miniaturizing data. So like nanoscale libraries. Remember microfiches? I'm saying remember like I've used one, but in spy movies, you go to the library and then you go and you get your newspaper on the microfiche and you zoom in and you find the story and you've figured out that the killer is actually the same person from 3 generations ago, and wow, story. So it's similar to that. So they're shrinking. Just rambling. They're shrinking it down and they're putting it in some kind of like epoxy resin, and it's stored
forever.
Arguably so, yes. And so they're calling these libraries, although I kind of feel like as a library, I want to be able to visit and dig out a book. These ones are going to be on the moon. So it turns out that data is not the only thing they're putting. So apparently the moon one had a lot of the English Wikipedia on it, plus 1 or 2 private collections, which I thought was interesting. And then they also were bringing samples of human DNA, which apparently were hair follicles, and these tardigrades. So if you don't know what a tardigrade is, watch Star Trek Discovery and then shrink that thing down.
We're not saying Star Trek Discovery was an accurate description of them. They can't actually travel through the mycelial network.
But they do look like what they look like.
They look like the most alien things.
6-legged, blobby things with sphincters for faces. That's what they look like.
And a tiny hand on the end of each leg.
And they're kind of cute.
I don't think.
No, I think they're
horrifying.
I think they're really cute.
I might not hug one, but I think the real size is like less than 1/10 of a millimeter on average, something like that.
Yeah, I was a bit disappointed when I found that out. I was really excited. Like, oh, look at that, it's amazing. Oh, it's tiny. That's a microscope.
So this leads you to this story, which is the thing that the press sort of picked up on, which is that the tardigrades may have survived. And by survived, that sort of got blown into, there's now a little happy colony of tardigrades living on the moon, and that's probably absolutely inaccurate.
They've elected a new king.
But the tardigrades were picked by the ARC Foundation for reasons which are not clear on their website. They said there'll be more information coming soon on.
Just to check when you say that the kind of idea of taking that particular species rather than the individual
Well,
members
they
of the
picked,
population?
obviously, human DNA.
They weren't like interviewed. There wasn't some kind of like CV submission process for each tardigrade.
I would love to know what the decision process was there, because they were like, yes, we're preserving all of human
Lovely sense of
knowledge, and
humour.
we're going to send some DNA samples, but let's send some tardigrades too. And so
I just want to see the selection process for the tardigrade astronauts. All the training montages,
Yeah.
the little helmets they had to wear, getting in their suit.
Using gyroscopy things. Oh.
I think we're joking about all this, right? No.
Incidentally, so they survived.
tardigrade right
Did the
stuff.
library survive?
Well, but again, surviving is a relative term,
Oh, okay.
right? Because they were in what's called the hibernation state. You dehydrate a tardigrade. This is one of the reasons they were probably picked, and I won't know yet until that website updates. But they were probably picked because they're very hardy life forms. So they're microscopic, but they can survive in extreme conditions, and you can dehydrate them. And this puts them into the super survival hibernation mode. So they sort of curl up into a wee ball. And then the minute you bring water back into the situation, they can revive themselves. And some of them have been revived after really long periods of time, like 30 years or something, stored in cold storage, and you can bring them back to life. It's kind of cool, right?
Brilliant.
So tardigrades don't win the most extreme living organism that's around, but they are interesting. So this is why they were sent. So it's the dehydrated ones have been encased in this resin as well. And so they're part of the package. So those might have survived the force of impact.
But does this mean
there's no liquid water on the moon,
Right.
so it's not that they're going to spring to life.
They're still
Plus,
asleep.
They are resistant to UV, but they're not immune to it. So ultraviolet radiation, which is, if you're on the surface of the moon, going to be bad. Unless you're in a shadowy crater, that's another story. It will eventually kill them off. So so even the dehydrated ones can't survive being blasted by intense UV light for a long period of time. So over time, they will be dying off as well. But the story itself is interesting because it's one of those things where, do we care? The moon is there. We're pretty sure the moon is sterile. But then it raises this whole question of forward and backward contamination. And there are rules in place. And nation states, i.e. the NASA space agencies and the ESA space agencies, are very keen to follow those rules. But private companies, I'm not a space law expert. At some point, we will try and sit one down in this room so you can hear from one. But they're not necessarily beholden to the same rules. So there is the Outer Space Treaty that we've all agreed on for some time now. In the 60s, they put this together, basically about non-proliferation. Can't say that. Nukes in space, Ken. But they also had planetary protection folded in. So one of the articles in there says we are not going to unduly mess up an environment that we're going to go to. And likewise, we're not going to bring stuff back to Earth without proper procedures in place.
So this company basically just went, yeah.
Well, the moon is, you don't need to follow stringent guidelines for the moon because it's considered a very interesting geological place, but it's not considered a place where the story of life and living organisms is potentially you're going to have either the risk of contaminating that environment or bringing it back to Earth. So the rules it gets really complicated. And I'm sorry, I didn't have enough time to read into everything, but the moon is kind of like a grade 2. Grade 1 is like the sun. It's like, throw whatever you want into the sun. Grade 2 is the moon. Which, yes, it's pristine, but it's also kind of inhospitable and sterile, as best we know. Arguably, the surface is like that. Maybe if you drill down, not so much. So that's where the questions come. Then you get into grade 3 and grade 4. So grade 3's Titan isn't even a grade 3, but Titan should probably be. So they need to sort of update the definitions as well. But basically, Mars has the more stringent ones. Mars arguably has places on Mars where you could conceivably even have liquid water survive. Maybe below the soil for sure. So if you have missions that are going to go to there or use Mars as a flyby, you run the risk that your mission might crash into Mars. So you have to follow more stringent protocols. And by protocols, I mean you're trying to reduce the bioburden on your spacecraft. So you're deliberately not sending tardigrades to Mars. You're sterilizing your spacecraft so that if and when you do go to Mars, A, your science experiment isn't going to have false positives because you brought Earth bacteria with you. And B, you're not going to basically mess up the biosphere that you just landed your spacecraft in. So these rules get taken really seriously.
Well, unless you're Elon Musk. In which case you just send your Tesla there,
But again, the Tesla was never designed to fly near any other bodies. So if it had, he might have got in trouble. But yeah,
I
you see what I
know.
mean?
So why did they send them?
That's what I don't know. I don't know why they thought tardigrades and DNA. I mean, I get the library thing, and that's quite a noble effort, I think. It's
I get the DNA. If you want to leave a record of the human race.
Yeah, but why did you choose that?
Done a picture or, got the DNA chain shrunk down in code form.
Yeah, but that's then going to be
that bit
decoded.
in Jurassic Park.
But again, the DNA sat in ultraviolet radiation up there. It's not going to look like DNA anymore. Right?
Well, I
Yeah,
assume
you record the information, not the
unless
the
it was
actual
supposed to be
thing itself.
in a wee protective box, but cosmic rays could still smack into it. So
I suspect if you had a small shielded box, you'd have the maximum lifetime available. Putting the actual DNA there means you don't have to decode human coding.
But we have. Oh, I see. Sorry.
We have, but an alien civilization might not use the same, might not look at it in the same way we would. They might have their own way of understanding it, or they do the Jurassic Park style thing and clone us, and we can run around free on a desert somewhere on their planet, on a desert island somewhere on their planet, until we break out and
life finds a way.
Yeah.
I need my factor 50 for that, I think.
I still don't quite get it because
Tardigrades is weird.
There's quite a lot I don't
publicity,
get.
basically.
Well, they haven't really put their reasoning for the DNA samples of the tardigrade on the website as best. I mean, to be, I should maybe give them the benefit of the doubt, but I was kind of hoping for more on the story when I went digging. But it's more fun in a way because literally as of last night, the Rosalind Franklin rover, so the ExoMars rover for 2020 launch next year, is just being shipped off from Stevenage, and it's about to move to somewhere in Europe. What's it called?
I think it might be ESTEC. That's one of the major contributors for ESA.
Stands for, but that sounds right. So it's
got European in it.
They're going to make it pretend that it's on Mars and make sure it's okay. But what's really interesting is it has to follow very stringent decontamination protocols.
They just blast it with radiation.
Well, no. Oh. You can some spacecraft. We've done this in the past. You build it dirty and you nuke it. So you blast it with radiation, you can bake it in an oven for a long time, and you can do, you cover it in like hydrogen peroxide or whatever, and it kills everything off. But that's the build it dirty and launch it clean ethos, which isn't so good because inside it could still be a teeming mass of critters in sealed chambers and stuff. So they want to go one better because this mission's designed literally to look for life either existing or not existing, and whether or not it's going to find any. That's another debate. And I don't think anyone thinks that's likely. But they're looking for organics. So you can't just kill life and then go, because that dead stuff is still going to be on you. And then when you start running your tests, you could potentially have contamination there.
Build clean.
So you build clean. So the clean room is crazy clean. How clean is your average clean room? You've been in clean rooms, Martin.
I can't describe it in any useful manner. The clean rooms we tend to use are only kind of bunny suits, boots, and at a push we'll go full body bunny suit and a face mask, so your eyes are still exposed. I know you get the really high end ones, which are like...
Well, there was an ESA video that had them in the bunny suits, so it's still humans. They're not in some kind of crazy, virus chamber where the suit is like plugging into air, but at the same time they're not allowed to sneeze in the room, so they get sent out. And annoyingly, the humans are the biggest bioburden that rover will experience.
More robots.
But they're constantly testing it and they're swabbing the room. And then this led me down an extra rabbit hole, which was like, apparently, so there's a database of swabs that are from clean rooms. So ESA and NASA have been doing this for some time, and you can go online and order the cultures, and you can go and look through them to see if there's weird stuff in there, because clean rooms are some of the most sterile places on the planet, more so than an operating theatre, for example. And apparently there is a strain of bacteria. I say strain, it was a new genus was discovered, only found in clean rooms. And it's a hardy life form. And as far as the engineers were concerned, they didn't care as long as the biomass was low, so your contamination was low. But as for actually doing the analysis and seeing what's surviving in your clean room, that was how they managed to find it. And it might exist elsewhere, but only in the clean room do you see nothing else is surviving except this one little hardy organism. So obviously it's of interest to microbiologists and what have you. So I just thought that was a nice story, was that there are some things that still manage to survive, even if you take every single precaution. But the plan is to minimize it. So you just, so it's going to be cool.
As we were saying, life finds a way.
Life finds a way.
Thank you, Jeff.
Are you gold blooming?
Okay, so we'll come away from an odd headline to a probably equally odd but slightly misleading headline. There's a couple of them that I've noticed recently. And the first one that I've come across, I don't know why, but my phone, on your phone, you sometimes get headlines from various newspapers on the Google side of things. And these come from various newspapers, most of which I don't read, but I try not to ignore because I like to see what they're saying. I won't name the paper. I think we can. But there's a lot of stories about asteroids. And, asteroid twice the size of the Shard will skim past Earth next week. Asteroid the size of the pyramids of Giza will come flying past Earth. Asteroid, X many ton asteroid will skim the Earth's atmosphere. We only saw it 2 days ago.
I feel like we could add in, like 50s serials where it just kind of, there's a giant thing about to attack us, and you see people going, ah! And then it's all scratchy and it's just like panic mode announcement.
What I don't understand is, this happens all the time, and also they're not that big, like twice the size of the shard. Yeah, that's not that big. It's just, And when you say skim past the Earth, you mean might come marginally closer than the moon is.
Quite often isn't. It's like, it's only 3 times the distance to the moon. You're like, well, no,
really
I'm not
far
lying in bed worrying about the moon hitting us tomorrow. And that's
I
closer
don't know.
than these things are going to be.
But it seems bizarre because this is not news. This happens all the time. But I don't know why it suddenly hit the headlines. I assume there was a story about a particularly near pass, loosely described near pass. They got a lot of clicks, and they've realized that that's how you get more clicks.
Yeah.
And of course, this comes back to more clicks, more advertising revenue, more money. And that has been this like splurge of stories.
I think we're getting better at finding these things. I mean, literally, we're building telescopes to do that, which we quite often try and piggyback off and do nice science with. But there are remits. I think NASA has a particular remit. I don't want to say NASA, actually, because loads of other people are doing stuff, but NASA is one of the people who often does a lot of things to track X percentage of things. And it's almost like a government mandated requirement that one of the things NASA should do is look for 99% of objects bigger than a kilometer. 97% of objects
Which
bigger
they think
than
they've done.
Yeah. And so, obviously the numbers aren't made up entirely by politicians, but in collaboration with them, they come up with a sensible figure of what could be tracked. So we have all these telescopes now, which are basically just sitting dedicated to watch the skies and look for varying moving things. And because we're getting better at it, I guess these stories are more frequent as well. In the past, those things, as you say, they've been flying past the Earth for the last probably 4 billion years. Most of them miss. And we didn't have a clue. We didn't matter.
Was there one that got revised? Because in the past, there's been one that sort of got just a slight bump up because most things are in the no threat.
Or whatever it was called.
The no threat category. So for a minute there, it goes in the next category up, which is a tiny bit of risk. And everyone goes, oh my God. And then they run the numbers and it's back down. And they know where it's going to go. And it's fine.
There was one that was a story of, there's one that, if it gets perturbed, might come into range. It's like, but the chance of it being perturbed are tiny. Perturbed enough is even smaller. Like, again, this is a bit of a null story. And then slightly adding fuel to the fire, because there has been a few stories about asteroid Bennu, which OSIRIS-REx has reached and is now mapping. And asteroid Bennu is one that could come quite close to Earth. And NASA have sent a probe to look at it, amongst other reasons to kind of go, well, what's it made of? So if we did have to deflect it, how could we do it?
Yeah.
Elon Musk came out with a comment on Twitter of, to some NASA tweet saying, this is great, but we have no defense against asteroids, which, again, fairly true. Hasn't really mattered so far. People are working on it all the time. But because he pointed this out, again, media frenzy about why do we have a defense against this? What are NASA doing if not defending us against this? Obviously, we just need to find a defense. It's like, come on. This is, again, it's been on the cards for years. Why is it suddenly a big thing?
Because Elon Musk.
Yeah.
Everything's a clickbait. I need to now go and check on this tardigrade thing because I do wonder if the original press release was like, some of them might have survived in their dehydrated state, and everyone went, "Oh my God, there's a colony of tardigrades on the moon."
Damn people looking at clickbait stories. We've chosen to talk about 2 of them straight away.
Yeah, we have.
And say,
that's kind of what we
stories.
do. We things that pop up on my Twitter feed are the things I talk about.
Actually, kind of almost literally the point of this podcast.
I'm going to check ourselves, chat.
Sticking with the clickbait headlines, there was another one.
Yeah, there was another one about a star older than the universe, which had come up a few weeks ago. This appeared in a number of different places. And actually, it was one of the, I find that metric of like people come and talk to you and say, "Oh, what's this thing about this star?" I'm like, "Oh, hang on, I haven't read that news story. I need to go."
They don't talk to me like that.
So I went to have a look about this particular story. I spent quite a long time reading the wrong story, which was kind of intriguing. So there has recently been an announcement discussing the age of the universe. The age of the universe is considered to be about 13.8 billion years at the moment. That's right, isn't it? Or 30.7? 30.8? I think it's 30.8.
Got revised up a little bit.
Yeah, I think Planck put it up a bit, didn't it? 30.8. There is a particular star called Methuselah. I think I said that right. Which is about 14.4 billion years old, plus or minus about 700 million years. So within the error bars, it's fine. But there's something a little bit kooky about this. And I found myself reading a few stories about this particular star, and then realized suddenly I was trying to look for the recent paper discussing this so I could actually look at the paper rather than the news story. And it all pointed back to the same story from 2013. And I think what's happened is there's been another result, which was more, in some ways, a more intriguing result, which was discussing trying to measure the age of the universe using the results of the gravitational wave detection from a neutron-neutron star merger, which we spoke about a lot last year, which was an awesome event. And
that was the gravity wave detection.
Fantastic.
Yeah,
and you can use this in some way because it's a bit more like in astronomy, we have difficulty measuring distances when something is particularly far away. And we talk about a standard, sort of a ladder for distances, and we measure something nearby and something a little bit further based on that thing nearby, and then something based on the thing which is a bit further, and you kind of build up this map of distance.
But it can get a little shaky.
It does, and it gets pretty shaky. The intriguing thing about the gravitational wave measurements is that you can get a more precise distance measurement. And there was something recently which was sort of hinting at the idea that if you used this neutron-neutron star merger as a way of measuring the distance, that you could actually just give a slightly different age for the universe, and that this would actually allow Methuselah to quite comfortably fit within our age because the universe would have been a little bit older. Which actually I think is a much more interesting story, but somehow all the press articles got kind of a little bit merged and discussed the star story because it's much easier to describe and much more sort of immediately kind of headline grabbing. And so actually I think the more interesting story which is embedded within this got slightly lost. Which I think is quite, I don't know if that's good or bad. I think it's a bit of a shame in some ways, but maybe it's a clickbait. It got people to go and read the story because star older than universe is a lot easier to discuss than bizarre astronomical event kind of hints at saying something a bit kooky.
It's still the first of many, isn't it? For the gravity wave things is going to be more. And we've only really seen one. But then the same with the old stars. I mean, how many stars have they dated in the same technique? Is this the weird outlier that everyone likes?
This is a particularly odd outlier. A lot of the time we get our measurements of stellar ages based on populations of the stars. So you look at a large group of stars in like a globular cluster or something, and from that global population, you can get a really good precise age on the group. This one is kind of an isolated object. It's actually relatively nearby. It's only 190 light years away. And it's moving pretty quickly across the sky because it's so its relative motion to the background stars is quite high. So it's a star which has been studied for a long time, but you're trying to work out the age of the individual object out of its population, and that's quite tricky to do. I'm trying to think.
You don't have much data to work with. You've just got what you get from the star, and that's it. And then you have to then make some assumptions, I guess, about how stars get made.
Model the thing to death, effectively. And those modelling things all seem to hint at it actually being ridiculously old. It's quite a small object, so our star will live for 10 billion years, roughly. Yeah. It's about 70% the mass of the sun, so it could live as long as the universe. It's just surprising it was formed so early.
Sometimes it's a shame with the error bars, though, because you're kind of like, well, if it fits the thing that you already think is the right answer, then you're kind of like, well,
it's not that exciting, really, is it?
An error bar is an error bar, and somewhere in there is probably the safe answer.
But as I say, I think the intriguing thing, and actually something which I want to go and dig into more, maybe we'll come back to it, and I don't know why it didn't get more of the press, was the fact that there was this hint that you have a different way of measuring the age of the universe based around gravitational wave measurements.
I wouldn't even have the first idea how you do that with that data.
Started trying to read the actual paper and was like, I'm totally out of my gravitational depth. But I think that's quite a cool story. So maybe just pointing at
is it still too early for universities to have courses that are explicitly about the observational science that is now gravitational wave observatories? Because I'm not sure we're there yet. I think we're still working it all out from first.
It's still pretty new, isn't it?
Yeah, and I feel like I'm going to have to go back to school on this.
Yeah, I think we all are.
It's fun actually because there was a thing popped up this morning.
Hang on, you about to preempt his next
No,
link.
we can go on to the fresh headline.
There you go. Carry on. Yeah.
This was as fresh as they come, and this one isn't clickbaity. So if anything, I'm going to be the one flying the clickbait banner because I haven't really had the time to digest this thing. But LIGO this morning announced
LIGO being
the Gravitational Wave Observatory. So they're very they're getting good at this, and so they're up to 10, 20 discoveries now. So as they get alerts they alert the rest of the astronomical community. So their public alerts are available. You can go and see what's being alerted. And it tells you roughly where the error bars are on the sky, or where this gravitational wave event came from. And I get very briefly, that's if you smack two massive things into one another in the distant part of the universe, that creates enough of a ripple in the fabric of the universe that we can actually detect that ripple here on Earth a long time.
I love that expression.
It's
a ripple in the fabric of the universe. But it's kind of the best description you can get for it. But it just so sounds.
So it's kind of a cosmic kind of, and you feel the universe move, and you can measure it. And that's what's happening here. So every time they see one of these signals, they go, whoop, we've seen a thing, but they don't have precision. So they can't say to astronomers who use optical telescopes to go and look where that happened and see if there's any optical follow-up. This is what made the neutron star merger really exciting, because we got both.
Yeah.
And we want more of those. So they tell us really quickly. So the alerts that came on this morning, 2 of them happened, but very, very similar positions on the sky, like almost overlapping, but not quite, and within 21 minutes of one another. And there aren't many. That'd be one heck of a coincidence if this was 2 completely separate events happening in different places and different times. So getting all relative, you're kind of like, okay, well, that's not impossible, but it's improbable, shall we say.
Massively.
One of the other things that I've seen people on Twitter talking about, and I got added into that conversation this morning, I was like, oh, this is interesting, is you could potentially have evidence that this is the first dual event because it was a lensed signal. So not only did you have 2 massive things smack into one another that make the ripples and do the, you've actually got something else in between you and it that bends the light. Well, I say light bends the signal in the same way that you can do this for optical sources as well. So I do a little bit of microlensing with what I do, or at least try to. This is quite a dense subject.
So when you're referring to lensing, this is gravitational bodies, large gravitational bodies that sit between you and the thing you're looking at, which bend the light and essentially magnify it. Like you had a lens there.
Yes, so you get free flux in terms of photons, but it also has a similar effect for the gravitational waves. But
doesn't make sense.
But the important takeaway here is that you can have multiple images of the same object, and we can see this. So you might have heard of something called an Einstein Cross. If you haven't, Google that now, because they're kind of cool. And so an Einstein Cross is a quasar that's being lensed by a nearby galaxy or an intervening galaxy. The galaxy itself, all the mass of those stars clumped together is enough to bend the light of that distant quasar. The quasar is not perfectly aligned with the galaxy. So you see 4 separate images of exactly the same object. And it took us a while to work out that was even happening. But then that allows you to work out exactly how massive that galaxy is to be able to do that. So you can run Einstein's equations and you fold the numbers in, and it gets incredibly complicated, and you need computers to help model that for you. But you can get information that you wouldn't otherwise be able to get. And you're getting extra photons from the distant quasar. So quasar people like me get excited, and you see time delays. So one image can flash, and then maybe 100 days later, the second image will flash, and then another 50 days later, the third image will flash, and it's all because the light is traveling a little bit of a different length to come at you from all of these different angles. If you want to lens your own things, you can do this with a wine glass. Just look through the bottom of the wine glass at a distant light source, and you can create circles and warps and weird things. So this is a very
slightly different effect. Instantly, if that didn't make any sense to you, that's because you were lacking Ali's hand gestures. Honestly, in this room, that was clear as crystal.
And I realize we're going into this too deep for what is essentially a quick touch on something.
I think it's just...
But the take home is that you could potentially create a time delay between 2 images. So essentially, LIGO might have seen the same signal twice, but coming from slightly different directions on the sky because something massive helped to make the light make the signal. Stop saying light, because that's what I usually.
Yeah, that's the. I think to me. So we spent a long time before the podcast chatting and trying to realizing. To be honest, I was realizing how little I understood about gravity.
Me too.
And then Martin was like, "This should be on the podcast. Shut up, stop talking." Because the thing I find extraordinary about this idea is I never considered that a gravitational wave can be lensed. So the analogy which we
until today, me neither.
No, the analogy which we quite often talk about with. Gravity in space-time, and the one you always see in classrooms on YouTube and so on forth is this kind of stretched spandex latex sheet or whatever, and you put a big weight in the middle, and that's the distortion, which is what your mass does to space-time.
You just shout gravity, ta-da, and everyone's like, oh, or at least I am, because you're sort of throwing away one dimension there.
Well, yes, but then you can show how something would behave in that gravitational or that bent bit of gravity, but no, bent bit of space. By like rolling a marble past your weight, and you see the marble gets bent, and that's exactly what the light ray does when it gets lensed. It kind of it should be going in a nice straight line, which as all light does in normal space, but if the space is particularly distorted by a mass, your little marble or your light ray goes in a curve, and so you can see round corners effectively, which is the lensing. But the fabric space-time ripple malarkey, which is a gravitational wave, is the latex itself. So the ripple in the latex is also rippling along and then getting bent as it goes around something massive, which is just fantastic and mind-boggling.
I've been tending to think about everything as signals.
Yeah.
But it's maybe a bit too early for us to have the right analogy for this, because it's obviously something we're now going to have to talk about. We'll get an expert in.
I think we'll come back to this.
Yeah, definitely. It would be nice. But I think everything's signals, and signals travel at the speed of light. So when you're doing stuff, that signal can only move so fast. And the minute you put gravity in the way, gravity changes the direction that it's coming from.
Can I say that my hand gestures were really good there too as well? And none of you seem to mention that, but I thought mine was just as good as Ali's.
So I mean, there could be some other more mundane reason, but if it was lensing, that's potentially very interesting. And people on Twitter who are smarter than I am seem to think it's not entirely implausible. So stay tuned. Might hear a bit more on this, but it's another rare thing in a class of rare objects already. And woohoo! I love the weird thing. Clickbait.
I think at that point we're going to signal the end of the podcast as well. Thank you very much for listening.
And wait. Thanks all.
Bye. Bye.